Have you ever looked at the map on your phone and seen that little blue dot that shows exactly where you are? It moves when you move, and it always seems to know which street you're on. How does it do that? It feels a little bit like magic. How can a device in your hand know its precise location on a planet that is thousands of kilometers wide? It's not magic, but it is one of the most incredible technologies ever invented. It involves a conversation between your phone and outer space. Imagine you and your family are going on a road trip to a place you have never been before. You get in the car, ready for an adventure. In the old days, this would mean unfolding a giant, complicated paper map. But today, you just pull out a phone, type in an address, and instantly, a voice tells you where to turn. A blue line appears on the screen, showing you the fastest route, avoiding traffic you didn't even know was there. We use this every single day, and we completely take it for granted. But just a few decades ago, the idea of having a personal handheld map that knew your every move was pure science fiction. For thousands of years, explorers and travelers faced the same fundamental problem. How can you figure out your exact position on the surface of a massive, spinning globe? The answer was finally found not on Earth, but far above it. The solution isn't a single thing, but a whole team of robotic helpers flying silently overhead. They are part of a system called the Global Positioning System, or GPS. This system is made up of a network, or constellation, of more than 30 satellites. They are constantly orbiting the Earth at an altitude of about 20,000 kilometers. They are spread out in such a way that no matter where you are on the planet, you can always see at least 4 of them in the sky at any given moment. They are our man-made stars, built for navigation. Each of these satellites has a very important and continuous job. It acts like a lighthouse in space, constantly broadcasting a simple radio signal down towards Earth. This signal contains 2 key pieces of information. It tells everyone who is listening exactly where the satellite is in its orbit, and it tells them the exact time the signal was sent. To understand how this works, imagine you are standing in the middle of a huge, dark field. You shout, "Hello!" and one friend, standing somewhere in the dark, hears you and shouts back. Based on the sound, you know your friend is out there, but you can only guess the distance. You don't know the direction. They could be anywhere in a circle around you. The GPS receiver inside your phone or your car is like you in that dark field. It's constantly listening for the signals being broadcast by the GPS satellites. When your phone receives a signal from just one satellite, it does a quick calculation. It compares the time the signal was sent with the time it was received to figure out how far away that satellite is. But knowing you are, say, 20,000 kilometers away from one satellite isn't very helpful. You could be anywhere on the surface of a giant imaginary sphere with that satellite at its center. This is where a second satellite comes in. Your phone picks up another signal and calculates its distance from that one too. Now your phone knows it's on 2 different spheres at the same time. When 2 spheres overlap, the line where they intersect forms a perfect circle. Your phone now knows that your location is somewhere on that enormous circle, which could wrap around the entire Earth. You're getting closer. The real breakthrough happens when your phone hears the signal from a third satellite. It calculates its distance from this third point in space and draws a third imaginary sphere. In only 2 possible points. One of those points is your true location on the surface of the Earth. The other point is usually somewhere way out in space or moving at an impossible speed, so your phone software can easily ignore it. And just like that, by listening to 3 signals, your phone has pinned down your position on the globe. This clever method of finding a location using distances is called trilateration. So that's it then. All your phone needs is to hear from 3 satellites to find its longitude and latitude. Well, almost. There is one more hidden, mind-bending problem to solve. Time. The radio signals from the satellites travel at the speed of light, a universal constant. It is the fastest speed anything can travel in the universe. Your phone measures the tiny amount of time it took for the signal to travel from orbit all the way down to your hand. It's a journey that takes less than 1/10 of a second. Using a simple formula from physics, your phone can convert that travel time into a distance. The formula is just distance equals speed multiplied by time. But for this to work, the measurement of time has to be unbelievably accurate. This is where the real genius of GPS is hidden. If the system's clock is off by just 1/millionth of a second, your calculated position could be wrong by 300 meters. A tiny error in time creates a huge error in location. An error that big would make navigation useless. It would be the difference between your map showing you on the highway and showing you in a field half a kilometer away. To solve this, every single GPS satellite is equipped with multiple atomic clocks. These aren't like the clocks on your wall. They are the most precise timekeeping devices ever built by humans. An atomic clock is so stable and so accurate that it would take over 100 million years for it to be off by even a single second. This ensures the time sent by the satellite is perfect. But what about the clock in your phone? It's just a simple, mass-produced crystal oscillator. It's good enough for your daily alarm, but it's wildly inaccurate compared to an atomic clock. This seems like it should be a fatal flaw in the system. If your phone's clock is wrong, how can it accurately measure the signal's travel time? All its calculations would be incorrect. This is the brilliant reason why your phone actually needs to listen to a 4th satellite, not just 3. That 4th signal is the key that unlocks it all. The 4th satellite signal provides an extra measurement that doesn't just help find your location. It allows your phone to solve for a 4th unknown variable, the error in its own clock. With 4 signals, your phone has enough information to run a special algebra problem. It calculates its position in 3 dimensions, latitude, longitude, and altitude, and it also calculates its own time error. In an instant, your phone's receiver figures out exactly how off its internal clock is, and it corrects for that error in all of its distance calculations. It synchronizes itself with the atomic clocks in space. It's like listening to 4 perfect musicians. If your own sense of rhythm is off, you can use the 4th one to adjust yourself and get perfectly in sync with the whole orchestra. And if that wasn't amazing enough, engineers also had to program the system to account for Albert Einstein's theories of relativity. Because the satellites are moving so fast and are so far from Earth's gravity, time literally ticks slightly faster for them. Without correcting for this, GPS would fail within minutes. So when you look down at your phone and see that comforting blue dot, you're not just looking at a point on a map. You're witnessing the incredible result of a cosmic performance. You are seeing a dance between a constellation of satellites, the fundamental laws of physics, and some of the most complex mathematics ever put into practice, all happening in real time. The big insight is that GPS isn't really a positioning system at its core. It is, first and foremost, the most accurate timing system ever deployed on a global scale. It is a giant, invisible clock in the sky built by engineers to allow anyone, anywhere, to solve one of the most ancient human questions: where am I right now? All of this breathtakingly complex science and engineering, atomic clocks in orbit, relativistic corrections, and high-speed signal processing, is completely hidden from us, working silently behind a simple, friendly interface. The system works so perfectly and so reliably that we forget it's there. It guides us through unfamiliar streets, helps farmers tend to their crops with precision, allows airplanes to land in bad weather, and tells you exactly when your pizza will arrive. The next time you pull up a map, take a moment to look up. Remember that there is a team of silent guardians in orbit, constantly shouting the time through the vacuum of space just to help you find your way.